So with that understanding of the iteration levels that we have in model fitting, that helps us in building a custom metric or any other custom function, we'll get into understanding how a custom metric was built. So, okay, let me first talk about the metric that we are going to build now. Custom metric, it is going to be here. We are going to build false positive rate, and we'll also learn how similarly we can build other metrics such as F1 score, odds ratio, or anything else. Also, before we start, TensorFlow already has a metric for false positive to get the false positive, but it does not have false positive rate. There is a minor difference between these two, but it matters for our case. Let's start with defining what a false positive rate is. Let me call this FPR, sure. FPR is equal to the false positives over the total number of negatives. We went through what false positive and negatives mean in chapter 1, but I'll again mention in context of a confusion matrix, prediction and truth, 0, 1, 0 and 1. The false positives are the cases when we are falsely predicting a sample as 1 when it is truly 0, which means this particular cell, false positive, it is truly 0 but we predict it as 1. And the denominator, which is the negatives, is basically the total number of zeros we have, so basically this entire row. This is true positive. If we are interested, basically this formula is equal to FP by FP plus TP. But for our custom function definition, this is not very important. This is only for quick revision of what this means. Alright, so this is what we are gonna build, a custom function that can estimate this false positive rate. So now we are going to build a custom function for estimating false positive rate during the model fitting.